Hi math students, it's Mrs. Marcellus and I'm here with my friend Furkat. In this lesson we're going to learn to write and solve subtraction equations. Today's learning objective: students will write and solve subtraction equations by creating models, applying the addition property of equality, and using standard algorithms. Today's vocabulary word is addition property of equality. If you add the same number to both sides of an equation, the sides remain equal. The addition property of equality is used to solve subtraction equations. Hey Furkat, that sounds an awful lot like the method we use to solve those addition equations, doesn't it? Are you ready to try some? Then let's go to our first example. Let's solve the equation x minus 7 equals 5. Solving equations is a lot like detective work. First we have to locate the variable, and then we have to isolate the variable, or get it all by itself so we can determine what it is equal to. In order to solve using a standard algorithm, we will apply the addition property of equality. When we apply this property, we are going to undo subtracting 7 by adding 7. When we add 7 to both sides of the equation, it keeps the equation equally balanced. Then we can do our calculation. Taking away 7 and adding 7 cancel each other out, and that result is 0. That leaves us with x plus 0 on the left, and we will write just x. On the other side, we will add 5 plus 7, which equals 12. If you want, you can draw the railroad tracks to keep everything separated. And of course, our final step is to check the result. We will plug it back into the original equation, and we'll put 12 in for x, and check to make sure that 12 minus 7 does equal 5. Let's solve r minus 2 1/10 equals 17 3/10. First we locate the variable, and then we isolate the variable. To undo subtracting 2 1/10, we will add 2 1/10. Those two combined equal 0, leaving us with just r on this side of the equation. And to keep our equation balanced, we will add 2 1/10 to the other side. When we add them up, we have 19 4/10. Then we will go back and check our solution. 19 4/10 minus 2 1/10 does in fact equal 17 3/10, so we know we have found the actual solution. Next, let's try an example with fractions. First we will locate the variable, and then we will isolate it by applying the addition property of equality. This means we'll have to add 3/5 to both sides of the equation. Subtracting 3/5 and then adding 3/5 cancels that out, leaving us with t on the right-hand side. When we add 2/5 plus 3/5, we add the numerators, and the denominator stays the same, giving us 5/5. So 5/5 equals t. We can simplify 5/5 to 1, which gives us our final answer of t equals 1. We can go back and check our solution by starting with 5/5 and subtracting 3/5, and we would subtract the numerators. 5 minus 3 is 2, and the denominator would still be 5. Since this is a true statement, we know that 5/5 or 1 is the solution. Let's try some word problems in which we will write and solve a subtraction equation. In the United States, about 3.7 million homes have a pet bird. This is about 32.4 million fewer homes than those with a pet cat. About how many million homes in the United States have a pet cat? Since we are writing and solving a subtraction equation, we know we'll need a subtraction sign and an equal sign. Next, we'll have to identify the numbers we need. About 3.7 million homes have a pet bird. This is about 32.4 million fewer than those that have a cat. Therefore, I will subtract c minus 32.4 and set that equal to 3.7. This says the number of homes with a cat, minus 32.4 million homes equals the number of homes with a pet bird. To solve, I will locate the variable and then isolate the variable by adding 32.4 to both sides of the equation. Doing so will eliminate the 32.4 from the left side of the equation, leaving me with just c. On the right side, I will add these two together and get 36.1. 36.1 million homes have a pet cat. I also could have set up my original equation to be c minus 3.7 equals 32.4. Adding 3.7 to both sides will still give me the same result. Of course, you can check your solution by plugging it back in and testing to make sure that 36.1 million minus 32.4 million does in fact equal 3.7. A dog's cerebral cortex, the part of the brain in charge of cognitive information processing, has 160 million neurons. This is 140 million neurons less than a cat's brain. How many neurons does a cat's brain have? Since we're forming a subtraction equation, we can set it up putting in our subtraction sign and our equal sign. The dog has 160 million neurons. This is 140 million neurons less than the cat. So therefore, we're going to have the cat's brain minus 140 million neurons to equal the dog's brain of 160 million neurons. To solve this equation, we will have to add 140 to both sides, and we'll get our result of c equals 300 million. Then we can test our answer and subtract 140 from 300 just to make sure that we have the correct solution. We also could have written the original equation as c minus 160 equals 140, and we still would have achieved the same result. Well, Furqat, that is most impressive. I had absolutely no idea that cats had so many millions of neurons in their brains. I suppose this proves what you're always telling me, that you're much smarter than dogs. I suppose you also think that you're a lot smarter than humans too, don't you? Well, I guess we'll have to do some research and find out about that. Well, math students, this concludes our lesson on writing and solving subtraction equations, so Furqat and I are signing off for now.